Have you ever wondered why biting into a lemon makes you pucker up? Or why soap feels so weirdly slippery in your hands? Well, that's not magic. That's chemistry. And it's happening all around you, all the time. Today, we're going to dive into the invisible forces that shape our everyday world: acids and bases. So let's start with a little riddle. What could a super sour lemon and the painful sting from an ant possibly have in common? I know, they sound completely unrelated, right? But stick with me, because by the end of this, you'll see how they're just two sides of the very same chemical coin. All right, so where do we even begin looking for clues to solve this? Well, believe it or not, the first one is right there on the tip of your tongue. Turns out, our senses are actually pretty amazing chemical detectors. I mean, really think about it. That sharp, sour taste you get from vinegar, lemons, even some yogurt, that's basically your taste buds shouting, "Hey, we've got an acid over here." And on the flip side, that kind of bitter taste and the slippery, soapy feeling of things like baking soda, that's the classic signature of a base. See? It's chemistry you can literally taste and feel. Okay, so we've got our two main players on the field, acids and bases. Let's put them head to head and really see what makes them so different from each other. So here's the classic showdown. We know acids are sour and bases are bitter. But when you get past taste and touch, the real surefire scientific test uses this stuff called litmus paper. It's super simple. Acids turn blue litmus paper red, and bases turn red litmus paper blue. It's like this simple color swap that acts as a secret decoder for their hidden chemical identity. And listen, this isn't just some weird stuff you only find in a science lab. Take a look at this list. We're talking about the acetic acid in your salad dressing, the citric acid in your orange juice. Heck, there's even powerful hydrochloric acid in your own stomach right now. And on the other side, you've got sodium hydroxide in soap and magnesium hydroxide in stuff like milk of magnesia. They are literally in our kitchens, our medicine cabinets, they're even inside us. Okay, so we know we can taste some of them, but you should definitely not go around taste testing everything to see if it's an acid or a base. So how do we tell them apart safely? Well, nature's actually given us these incredible little chemical detectives called indicators. And an indicator is, well, it's pretty much exactly what it sounds like. It indicates the chemical nature of something just by changing its color. It's like a secret agent that goes in and reveals whether we're dealing with team acid or team base. Let me show you this in action with something that has probably happened to all of us. You're enjoying a great meal and, whoops, you get a bright yellow turmeric stain right on your shirt. We've all been there. So you rush to the sink, you grab some soap, and you start scrubbing. You're just trying to get the stain out, right? But then something kind of weird happens. And poof, that yellow stain suddenly flashes to a deep reddish brown. Now, that's not a news stain, that's a chemical reaction happening right before your eyes. The turmeric is acting like a completely natural indicator, and that color change is basically screaming at you that the soap you're using is a base. How amazing is that? And turmeric isn't the only one. You've got litmus, the classic one from the science lab, which actually comes from lichens. And you can even make your own indicator at home using China rose petals. Just steep them in warm water, and you've got a liquid that turns a beautiful dark pink in acid and green in a base. Nature is just full of these little chemical spies. All right, so we have these two opposing forces, acids and bases. The big question is, what happens when they finally meet? Well, that brings us to the main event, the most powerful reaction in our entire story, neutralization. And again, the name pretty much says it all. When an acid and a base get together, they literally neutralize each other. They just cancel each other out. The sourness of the acid and the bitterness of the base, they're both completely destroyed in the process. So here's the play-by-play. You mix the two together, all their defining properties just disappear, and in their place, two totally new, totally neutral things are created: plain old salt and water. Oh, and this little chemical battle always gives off some heat. And this right here, this simple, elegant equation is the whole thing in a nutshell. Acid plus base gives you salt plus water, and a little bit of heat is always released. It's a perfect chemical balancing act. Now, this whole balancing act isn't just some cool chemistry trick. It is an incredibly powerful tool that we use to solve real-world problems every single day. You know that awful burning feeling of indigestion? Well, what's actually going on is that your stomach, which uses a really strong acid to digest food, has just gone into overdrive and produced way too much of it. So what's the fix? You take an antacid. Get it? Antacid. It literally fights the acid. That stuff is a base, like milk of magnesia. It goes down into your stomach and performs that neutralization reaction we just talked about, calming everything down and making you feel better. That's chemistry working as medicine. And now let's circle all the way back to our first question, that pesky ant sting. What is the chemistry going on there?
When an ant bites you, it's actually injecting something called formic acid into your skin, and that's what stings so much. The quick fix? Just rub a little bit of baking soda on it. Baking soda is a base, and it neutralizes that stinging acid right on your skin. So there you have it. The connection between a lemon and an ant sting is that they both involve an acid. And this idea scales up in a huge way. Farmers use bases like quicklime to treat soil that's gotten too acidic for plants to grow. And big industrial factories use bases to neutralize their acidic wastewater before it can be safely released back into our rivers. It's a reaction that literally helps keep our world in balance. So from the taste on your tongue to the soil under our feet, this constant battle and truce between acids and bases is shaping our world all the time. Now that you can spot the clues, the real question is, what else in your world is just waiting for a little chemical neutralization?